All right. Well, hopefully you guys can hear me. Yes. Sí. Hola, ¿cómo estás? This is not Spanish class, though. This is math class. I'll wait until I see a response. Okay. So, some people had some issues a little bit yesterday. So we're going to do a little review. I'm going to give you guys some advice, and hopefully you take my advice. If not, that's fine too. When you're dealing with math, the first rule of math is going to be don't get frustrated before you get started, and don't get frustrated as you're doing it either. Once you begin to get frustrated, you need to take a break because it's probably not going to end well, right? And with these problems, they're not as hard as they look. Okay. So we're going to go back to page 417. What you have to do is you have to remember how we said that we solve these problems in the first place, right? It gives you the steps, right? The first step, if you look on page 416, is multiply the coefficients. Multiply the coefficients. Now, if you don't know what a coefficient is, if I'm writing something like 3x, this is the coefficient. It's the number by which the variable is being multiplied. That's the coefficient, right? The second step is to add the exponents of each like base. So when you're looking at these, if you just follow these steps, it becomes very easy to figure out what your answers are, right? So let's look at on page 417, number 1, right, which is 3y to the 4th power times 8y to the 2nd power. Okay. The first step, multiply the coefficients. What are our coefficients? Well, are the 3 and the 8, right? I guess I can just, I wonder if I can bring this down here. This would be helpful. Well, I guess I'll figure this out later. Anyway, so our coefficients are 3 and 8. So 3, you multiply the coefficients. That's the first step. So you have 24. That's the beginning of your answer. Now you add the exponents of the like bases, right? The like bases, right? Y and Y, right? 4 plus 2 is 6, right? So your answer is 24y to the 6th power. That's it. All you're doing for these is multiplying the coefficients. Let's look at number 2. 4c to the 3rd power times 5c. Right? What are our coefficients? Our coefficients are 4 and 5. So we multiply our coefficients. 4 times 5 gives us 20. Right? and then we add the exponents of the like bases. Now remember, and this is easily forgotten, but remember that the c here has an unstated exponent of 1. So it's 3 plus 1, which would be 4. So our answer is then 20c to the power of 4. Does everybody understand that? You don't need a book. You're just listening. Jack, you gotta stop typing stuff in unless you got something to say, brother. Please. All right. So if you have an issue with those, please let me know so we can spend some time on them. If you don't understand how to get these answers, please let me know and I can give you a call, or we can spend some personal time going over these. So let's go to the division. First, number 22, 12x over 4. Okay. And obviously, the way we're getting this is simply by doing the division, right? 12x over 4 is going to be 3x. You just retain the variable. It's 3x. Number 2, or 23, 120a to the 4th power over 12. How many times does 12 go into 120? 10 times. 10a to the 4th power. Number 24, 50xy over 10. What's the answer? 5xy. Right. Very simple. If you have a problem like number 25, where it's 20a to the 3rd power over a to the 2nd power, what do I do with my exponents? Who remembers what I do with my exponents if it's division? No. You subtract them. You subtract them. If it's 20, I'm sorry. If it's 20a to the 3rd power divided by a2, these get subtracted, 3 minus 2. So what you end up having is 20a. Because it's a 1, you don't have to state that, though. It's just 20a. You can put the 1 there if you want. If it's division, you subtract the exponents. If it's a negative number, then it's a negative exponent. If it's 5 minus 7, it's negative 2 is the exponent. Does everybody understand that? You're only adding exponents with multiplication. So addition, subtraction, you're carrying over the exponents. Multiplication, you're adding the exponents. Division, you're subtracting the exponents. You should write that down on a piece of paper. You should have if you were smart, you'd have this written down so you know, okay, I'm dividing exponents here, or I'm dividing numbers with variables and exponents. I know I need to subtract these exponents. And it's the numerator's exponent, subtract. You have the numerator's exponent and you subtract the denominator's exponent. So you take this one here and subtract the 2, right? If you don't understand these, if you're thinking, well, I'll just figure it out later, you're probably going to fall behind. Just saying. I want you to look at here's number 34. If you don't have the book, that's okay. But what this says is 4j to the power of 2 times k to the power of 4 divided by j to the power of 2. And I know when you're looking at this, you're thinking, yeah, right. What in the world? This is one of the problems where you need to take a breath, take a step back and say, okay, let's take it one step at a time, right? If I know I'm subtracting exponents, right? So I know that this j is going to cancel itself out because it's 2 minus 2. So j to the power of 0 is 1. So essentially, I don't need to even put that there anymore. The answer doesn't have to have j in it anymore. It'll have 4, but not j, because it cancels itself out, right? Everybody see that? I have to subtract these exponents with the like bases. It's going to end up canceling itself out. So my answer is 4k to the 4th power. I don't have anything to divide here, right? Does everybody understand? Or if I do, it's 4k to the 4th power divided by 1, which would be 4k to the 4th power. Does everybody see that? Is anybody completely confused by what I just said? Let's look at one more. But you know what? I can save my whiteboards. That's interesting. Okay. You're completely confused. Okay. Let's try to get you unconfused. Let's look at this one. 9. Nope. I don't want red. 9s. Do you have your book with you, Jack? Jack Callahan. I know Jack Nunez doesn't have his. Okay. Look at number 35, just so you have a point of reference as we walk through this. It's 9s to the 3rd power divided by or over 16s to the 5th power. Okay. Now, what are we going to do with these exponents? We're going to subtract them. So I know I'm going to have a negative number, right? Because 3 minus 5 is negative 2. Right? So you could try to divide these and give some sort of a decimal. Well, you really can't actually divide them. So what you're going to end up having, the only way to really simplify this, because you can't really divide because you don't know what s is. Hold on a second. So you're going to have, essentially it's going to be 9s to the negative 2nd power over 16. That one's kind of tricky. Let's try a different one. Let's do 36. So it's essentially a to the second power. Oh, that's not an a, that's a 9. A to the second power, b to the second power over, or divided by a to the third power times b to the fourth. So it's the same method as we were using for the when we're doing multiplication, right? It's multiply the numerical coefficients and then you're going to add the exponents. Or I'm sorry, subtract the exponents, right? I just said that completely wrong. You're going to do the exact opposite. You're going to divide the numerical coefficients and subtract the exponents, right? As opposed to multiplication. So when you're doing multiplication, it's multiply the coefficients. My drawing skills are... right? And you're going to add the exponents. If you're dividing, you're going to divide the coefficients and you're going to subtract the exponents, right? So the numerical coefficients for this one here, it's actually 1a to the second power times 1b to the second power divided by 1a to the third power times 1b to the fourth power. That's really what you're looking at. Because the 1 is unstated, but it's there, right? So essentially, one time, the ones mean everything's going to pretty much stay the same. So what you have then is dealing with the exponents. What I want you to do is I want you to separate your like terms, right? So let's separate our like terms. As a matter of fact, let's... A2, B2, again, I'm drawing 9s. Divided by A3, B4. All right, so let's just say, forget everything I just said. Let's start fresh, okay? Take a breath. Let's walk through it, all right? First thing I want you to do, and the other way to write this, obviously, you might see this in this form instead, which is the same thing. It's just another way of writing it. You might see A2, B2 over A3, B4. I want you to rewrite it like this. All right. This is page 418. I want you to rewrite it like this. So if it's given to you like this, I want you to rewrite it like this. And then what I want you to do is I want you to separate out your like terms. You have A2 and A3. And then you have B2 and B4. Okay? The reason you want to do that is because now what you're going to do is you're going to deal with the exponents. Okay? 1 A2 and 1 A3. You're going to subtract these exponents, right? So what do you end up with? 1 A2, 1 A3, 2 minus 3 is negative 1. So you have 1A to the negative 1 power. Does everybody see how simple that is? That's all you're doing. That's the first step. That's your first part of your answer is right here. And it's just the result of taking this exponent and subtracting it, or subtracting 3 from it, right? You're subtracting the exponents. 1 times 1 is 1, so that gives you the 1a. You're multiplying, or 1 divided by 1 is 1. You're dividing your coefficients, and then you're subtracting your exponents, right? Now b2 and b4. 1 divided by 1 is 1, right? Gives us b, or 1b. And then what do we do with the exponents? 2 minus 4, which gives us negative 2. So that's our answer. And if you were to rewrite this, it's a to the negative 1 power times b to the negative 2. Again, the first thing we want to do is separate our like terms. Let's look at number 37, 6vz to the 5th power divided by 24z to the 6th power. All right. Again, if you're already freaking out, because this is, you don't even know what you're looking at, just pay attention to each step, okay? First thing we do is we divide our coefficients. So what you end up having is, let's deal with our exponents first. What's 6 divided by 24? Now you're going to get a decimal. What I want you to do when you get a decimal, and it's so 6 divided by 24 is going to be 0.25, right? That's the first thing we do, is divide our coefficients. So what are our coefficients in this problem? So when you write these out, just remember that first step is identifying your coefficients and dividing them. That's the first step. First step, forget the variables, forget the exponents. Identify your coefficients and divide it. 6 divided by 24 is 0.25, or 1/4. So 1/4 is going to be part of our answer. And then it's as simple as dealing with the exponents. What is 5 minus 6? What's -1? Right? If we're subtracting the exponents with like bases, we have a z and a z. 5 minus 6 is -1. The v doesn't have any other like base over here. There's no v, so we're just going to carry that over, and it's going to be vz to the power of -1. 1/4 times vz to the power of -1. All we're doing is finding our coefficients, the 6 and the 24. We're dividing them to get the 0.25, or 1/4, right? Are you still lost, Jack Callahan? Okay, good. It's not hard. Okay, let's look at one more. 14 number 38, which would be 14 PQ to the third power over 4Q. Okay. Now, if you're, like I said, what I want you to do with this is rewrite it 14 PQ to the third power divided by 4Q. Okay. That's what this is. It's the same thing as writing this 14 PQ to the third power divided by 4Q. The first thing I want you to do is identify your coefficients. Your coefficients, and this is supposed to be green, and it is not green. Your first coefficient is 14. Your second is 4. Right? When you have a fraction like this, where you know your number, if you do 14 divided by 4, it's going to give you 3.5. What you can do, I mean, you could essentially do the 3.5 times and then deal with the variables, or you can just it doesn't really matter. What the book is asking you to do is kind of stupid, but I'm going to tell you what they're asking you to do anyway. And if you want to do it this way, you can. They're asking you to take 3.5 and turn it into a fraction over 2. So 3.5 as a fraction would be, I don't know why they do it this way. Give me a second. Oh, wait a minute. So they want you to write it like this, 7 over 2. Because that's this reduced. It's 3.5. It's still 14 divided by 4. But they want you to give it as a fraction reduced instead of 3.5. Does everybody see it? It doesn't, I don't care if you do that. You don't have to do that. If you want to just give me the 3.5 and then deal with these variables and exponents, you can do that if you want. So, because I don't want to confuse you, the steps are simple. You're dividing your coefficients. I don't want you to worry about the book's going to give you something different, but I want you to identify the coefficient and I want you to divide them. That's it, right? 14 divided by 4, whatever that is, write it down. 3.5. Great. Let's move on to the next step. Now we have variables and exponents. There's only one with an exponent with a like base, and that's q. What is 3 minus 1? Because remember, it's tempting to think the q is 0, but it has an unstated exponent of 1. So 3 minus 1 is 2, right? So now we know we have a q to the power of 2. We also have a p that doesn't have any other like variable here. So we just carry that over. So it's 3.5 p times q to the power of 2. Or as they would want you to write it, 7 over 2 times p times q to the power of 2, which is the same thing as this. It's just writing it in a form of a fraction. Right? So again, find your coefficients, which are these numbers, divide them if it's a division problem, right? And then once that's done, find your variables with like bases, right? Or find your exponents with like bases and subtract them. And any variables that don't have like bases, just carry them over to your answer. Does everybody understand? So again, if we're multiplying, right? We multiply the coefficients and add the exponents. If we're dividing, we divide the coefficients and we subtract the exponents. If you were to write anything down, you would write those steps down. It's in your book, so you can go back to it. All right, any questions? I want you guys to do homework 10.4. If you don't have your book, I will upload it right now. I know that the website says that we're going to do the live stream at 1. I might have to push that forward a little bit. I have to go to the campus. So if I might do the grammar now, actually. Anyway, any questions or concerns? What's up? It blocked you out. Why did it block you out? Let me see. No, don't worry about the blue questions. Give me a second, Eric. I'm working on it. Huh. Can you try to take it? Did you try this morning, Eric? When's the last time you tried? (9:45 a.m.) All right. Well, try it again. I don't know why it would be blocking you out. So try to open it up this morning. Because like I said, there's no reason that it should be blocking you. I don't even know that that's something it can do. Yeah. Can you try now? All right, hold on a second. Let me see if I can't. That is unusual. Let me see here. Well, Bella was able to take it, so I'm not sure. Nothing ever works how you want it to, folks. All right, I'll fix it, Eric. Give me about 10 minutes. And then check it again, and I'll have it fixed. All right. And then I'm going to do that, and I think we're going to come back again and do the grammar. That way I can get that done before I leave. So I'll see you in a minute.